Welcome back everyone. Now we are actually going to start the numbers that I presented and started the course with, the 8086. But first of all, I decided to get a comparison to you so that we understand that why we are starting with the 8086. Okay, so let's write it here. So we are having 8085 on the one row, and let's have 8086 on the other row. And now we're going to compare it, and throughout the comparison we are going to learn a lot of things. So first thing that we are having here is size. On the basis of the size, it is 8-bit, means it can fetch, or you can say it can process 8-bit at a time, 8 zeros and 1. And 8086 can processes just the double, 16-bit, means 16 possible combination of the zeros and ones. Incredible, right? Now the next thing is address bus. So address bus. So in the address bus, what we are having here is 16-bit address bus. Well, I'm going to explain what is address bus just in a while. And it is having 20-bit address bus. You can see the clear comparison. It is getting victorious. The memory, sure, this is not the RAM and ROM, this is the memory of the processor that I was talking about. Like, it is storing the things for a few moments, but it requires, even if you are having content or register, you have to store something, at least a little bit of data. So it is having 64 KB of the storage, and trust me, even this is more, because you just have to store the location, not the exact address. And this is having 1 MB. Wow, humongous difference again. Now the next one is instruction. So instruction, so what we're having here in the instruction is, it does not support pipelined architecture. Well, let me write it also. Let's use a different color for the variety. Let's use the blue color here. It does not support pipeline architecture. Well, I'm going to explain the pipeline also, so don't get worried about this one. Architecture, don't go on my spellings, go on my words. Okay, now in this one it obviously supports the pipeline structure. It supports pipeline architecture or structure. Well, I'm just writing PA. Yes, it supports the PA. Okay, let's use the next page for the next data. As obvious, 8085 is here and 8086 is here. And now what we are having here as the next point is input output. So 8085 can address 2 to the power 8 input output, or you can simply say 256 inputs and output in one instruction cycle. And 8086 can access 2 to the power 16 instruction cycle, input output in one instruction cycle. One instruction cycle means when you just hit for once, it can do, in one operation it can do perform 16-bit of operation, and 8085 can do 8-bit of the operation. This is actually here that we have already discussed. Okay, now what is the next one? The most common one. As in the cost, surely it's low cost, because we are having everything half, and in this cost is high for sure. We just have improvised, upgraded our system, so surely the cost will go up. So this is the only winning part for the 8085 because the cost is low. That's it, nothing else. Okay, so let's first discuss that what we have left here and what it means. Okay, so my dear pondering people, what is the meaning of the address bus? Well, the address bus means the bus that is getting addressed. Yeah, something like that. If you have opened a USB ever, so you must have seen some lines, or in the devices you have seen some lines in the USB data cable. So what are these lines? These lines are buses. What are buses do? In the bus or on the buses, on these path, let me write that, on these paths, information, or actually betterly called as data, travels from one point to the other point, to the other point. Like, remember what we are having there? um we processes something, input and all that story, and then the output. So in between they are the buses. You can simply think it like the route or the path on which the information in the form of the voltage travels. As many as buses are there, that much fast is the speed. Like, here we are having 16-bit address bus, means 16-bit address bus. Getting my point? 16 possible path. Here we are having 20 possible path. 20 flow of the data can go in once. Well, I have never seen in the real life the 20 lane highway, it will too much, but this is the point here. So data can travel in the buses. So next time you see those lines, you can say that these are the number of buses. Exactly, my dear friend. So if you are having high number of buses, the speed will be high. If you are having low number of buses, you will have traffic, and because of that traffic the speed will get less down because it will go one after another. Like, if I have to travel two things at a time and I only have one address bus, so one will go first and then second will going to go on the same path, it will going to travel. But if you are having two different paths, two separate paths, well, let me distinguish it with this line. Now, one can travel through this way, two can travel through this way. So, one and two can happily travel with their consecutive speeds as whichever speed they are flowing. So, we can have the data simultaneously and half the time. Exactly. As much as the speed, that much is the bus. That much buses you require. Well, in the real life, I will like to call it the lane, but it is called as bus. That's it. So memory is 64 and 1 MB. Well, you surely remember that there can be more functionality, so there is more memory. There can be more space for the fetching, and there is less memory means it can fetch less. It can have it having a less things, just the less functionality it can do. It does not support pipeline architecture. What is the meaning of the pipeline? Let's understand this one. So, the concept of the pipeline is actually revolutionary. So, pipeline means the different pipes, or let's say parallel pipes. Um, let's say I am having two different pipes. I'm actually making the pipes so that you can visualize that how it's working in the data. So if you are having two operations simultaneously, we are having two pipes. So both pipe can perform the operations. But if you are having a single pipe, so and still if you have two data, like let's name A and B. So A and B processed. So I'm putting the dash so that you can differentiate. It is the processed data, it is unprocessed data. Now, if you are having A and B, well, they both will going to go through the same pipe, even though it's not pipe, but there's still a pipe. I will explain that. So A dash will come first, and then we are having B dash, the processed data. Like here it is written that 8085 is not supporting the pipeline architecture, means there is only one pipe. Don't get confused that it is having no pipe, because there is definitely one path in which the data flows inside the processor. Don't even get confused with the address bus. Address bus is the communication, is the highway between the processor and the input output and with the memory. So with the input output processor, memory and all that things, this is happening by the address bus. But inside the processor there is no pipeline structure, means there is only one path. And in the 8085 it supports the pipeline structure, and what I showed you here is the parallel pipelining. So this is parallel pipelining, you can perform two operations at a time. And in this one we have single pipeline, or if you add one more pipe here, even one more pipe here, what you are doing actually, you are just adding the pipe. This is serial pipeline and not getting much used obviously, but surely on the price basis this is high priced and this is low priced, because you are using just one path and here you are using multiple paths. Well, if you are just having to change the traffic light and the colors of the traffic light, surely you are not going to give so much upon that what you actually need to put on. So we don't want so much expense just to show the red light, yellow light and green light. So what we actually do here is very simple thing. We use the serial pipeline. But for the complex operation, we need and we require the parallel pipelining, because in the parallel pipelining, we have the freedom to use and operate two things at a time. You can surely see from here the clear distinction that previously it was impossible to open multiple screens at a time on the same screen. But with the advanced pipelining architecture, you can open up to 10 screens, maybe less or more depending upon the system. Like I can do work on my notepad, I can still having my podcast open, I am listening to music, I am teaching on let's say some kind of the presentation or PowerPoint you can say. So these are all the things that opened at once in my PC right now. So this cannot happen without pipelining. Pipelining can do one thing at a time, and parallel pipelining can do multiple things at a time. So this is going to change the entire evolution of the processor. Okay, let's see that if there is anything left. Well, we have covered these things. And now in the next one, to the power 8 input output over 16 input output, I think you get already the idea of it. And the cost is low and high. You surely get that why it is low and why it is high, because we used more and more functionality, more and more things in the 8086. So obviously 8086 will going to go expensive. Okay, few more words about the 8086 so that we can build a foundation for that. It is having 256 vector interruptions. Vector interrupts. TERUPPTS interrupts. Actually, one P will going to come. Ignore that. Okay, so it is having 256 vector interrupts. What it means? It is having 0 to 225, 0 to 255 means 256 technically. These are the 256. Numbers are assigned. Numbers are assigned. I know that you are wondering that what is vector interrupt. So this is the meaning of the vector interrupt actually. So 255, 0 to 255, technically 256 numbers can be assigned at once in 8086. That's fantastic, right? And just to satisfy our curiosity, let me tell you a few more points here. 8086 is having 29,000 transistors. 29,000. Well, uh, maybe this number is not seemingly surprising you right now, but let me tell you that the processor that right now we are talking about is not today's processor. This processor came in 1978. So if you calculate with 2022 when I'm shooting this course, so it is having 22 plus 22. It means 44 years back. Well, now it might surprise you. 29,000 transistors. That's humongous number. It is easy to multiply and divide, obviously in the 8086 because we are having more and more things that it supports. So these are the few things that I would like to discuss with you, and this is my reason I'm starting this course with the 8086 because this is what is getting in the evolution. You can call this as the first complete processor with the amazing features, and its family member is the Pentium. Yes, its family member is the Pentium. Remember, 80586 is Pentium 1. So technically, we are just proceeding with the family of 8086. Even today, like you are having the latest processor is actually the evolution of 8086 in the Intel world. So welcome to the world of microprocessor officially. Now you have all the basics that is required to understand the 8086, and now we can start learning the 8086. So get excited, my dear friend, and now we are happy, and let's clap on. Yeah, we are ready for the battle that we are going to win, and surely we're going to learn a lot. So see you in the next one. Till that time, take care, God bless, and keep learning.